Alright, so in this video I'm going to solve this problem 2 sine 3t minus 1 equals to 0. So the first thing I want to do is I want to isolate the sine 3t. So I'm going to move the 1 to the other side. And then I'm going to divide both sides by 2. So I get sine 3t equals 1 over 2. Now we need to solve this using our cast rule, but before I do that, I'm going to explain what this 3 over here means, because we now have a k value. So basically, let's get into a side explanation of this, because you've probably never seen this before. If I have sine t equals to, let's just say 0.5, we'll use the same value. Okay, and remember, this question is from between 0 and 360, so we're assuming the whole question is from 0 to 360. Well, if I have sine t equals to 0.5, I'm going to have two solutions. If I have sine 2t equals 0.5, my period is going to change here, so I'm going to have 4 solutions. If I have sine 3t equals 0.5, my period is again going to change. I'm going to have 6 solutions. So the value of k here affects the number of solutions between 0 and 360. And to kind of explain why, so I'll do one more example. Sine 4t equals to 0.5, you would have 8 solutions. So to explain why, I'm going to actually draw out the graphs and explain it. So this is just sine t, the first one that we did, and this is 360, and right here is 0.5, and if I draw a dotted line across, you can clearly see that we have 2 solutions over here. If I do sine 2t, that's gonna be like this. And this is going to be 360 because the period changes. So sine 2t means we have 2 waves in 360. If I draw my line across at 0.5, you can tell that we have 1, 2, 3, 4 solutions. And the same idea goes for the rest of them. That's why you keep getting more and more solutions. And once you learn how to draw sinusoidal waves, which is in the next chapter, you'll actually get a lot better with this. But just remember, if your k value changes, your period is going to change and you're going to have more solutions. Okay, so coming back here, we know our k is 3 from there, and period is always 360 over k. So 360 over 3, which is 120 degrees. Now this is going to be important to find our next solutions. But in order to start over here, I'm going to start with my cast rule. Now, where is sine positive in A and in S? Then I'm going to come back here. I'm going to do the sine inverse of 1 over 2. So if I do the sine inverse of 1 over 2 in my calculator, I get 30. So my first solution is 3t equals to 30. This is also going to be 30. So my second solution is going to be 3t equals 180 minus 30, which is 150 degrees. Alright, so now that I got this over here, I can divide both sides by 3. I can do it for both equations at the same time if I want, but I'll get my first solution as t equals to 10 degrees. And my second solution as t equals 50 degrees. So I'll actually even draw this out. I'll draw the 3 waves here in 360 so you can understand this perfectly clearly. That's 1, 2, 3. Not the best drawing. I know it's not 100% accurate, but it doesn't have to be super accurate for you to understand it. This is 360 right over here. So we don't care about the rest. And as you can tell, there's going to be 6 solutions here. So these two first solutions that I found are 10 and 50. Now there's 4 more solutions left. And in order to find these 4 more solutions, all I have to do is add 120 to my first 2 solutions. Because they constantly repeat every 120 degrees because that's my period. So my next one is going to be 130 degrees. And over here it's going to be 170 degrees. I'm just going to add 120 more to these two. I'm going to get 250 degrees. And over here I'm going to get 290 degrees. And these 6 are all my 6 valid solutions between 0 and 360 degrees for this question.